Alright guys, this is the first of two videos that you need to watch regarding the power requirements for your Raspberry Pi and your Hatboard. There's some major changes that have taken place compared to years past, and the power requirements for this year's competition are somewhat different. Now, the first major change is visible in this. We are running separate power supplies to the Raspberry Pi and to the Hatboard. Now, once these are on board your robots, this Hatboard is going to be connected to your Raspberry Pi, but we're running different power sources to each of these, okay? And the reason why we're doing this is we want to provide a nice, steady current to our Raspberry Pi. Now, remember, this is a microprocessor, not a microcontroller. It has an operating system on it, and if we are crashing our Pi because of power failure, we can essentially wipe out that operating system if it happens too many times. Now, we're running an additional power supply to the Hatboard, and the reason why we're doing this is because when you go and turn servos on, if we had these running off the same power supply, you actually create a spike in current, and that current draw that takes place could actually pull enough power away from the Pi to actually cause it to shut down. But if we have separate power sources running to each of these, this shouldn't be a problem as long as you have nice charged batteries running to each of these. Now, that brings me to my next point. I would strongly recommend, and there's no multimeter in here, but I can draw one. You want to start off anytime you use this with a battery that has at least 12 volts on it. We're only requiring 5 volts here, but if you have a nice fully charged 12 volt battery to start with, your run time is going to be significantly longer, and your robot's going to be far more reliable. Same thing with your battery for your Hatboard. You're going to want to start with 12 volts, and this is to make sure everything runs as smoothly as possible. So next thing I want to talk about is this little device that you see here, and this is called a DC to DC converter. The slang term for it is a buck converter, and what this does is it takes 12 volts input, which this side would be connected to the battery, and this little circuit here steps that voltage down to give us 5 volts. Now, there are some limitations to this device. It'll take 12 volts, step it down to 5 volts, give you a nice steady current, but that current is limited to 3 amps. Now, if for some reason you had, let's say 15 servos all hooked up to your Hatboard, and that Hatboard was being powered by just one buck converter, you're going to exceed the 3 amps that this is able to handle, and this actually has some circuit protection built in, and this will actually cut the power supply. So you really don't want to draw any more than 3 amps on this, and you'd really have a hard time doing that unless you had maybe seven servos all hooked up running simultaneously. Now, if you had 10 servos hooked up to this, but you're only turning off and on 2 or 3 at a time, then you're not going to have a problem. It's when we have these huge current spikes as a result of turning on many servos all at the same time. And as you can see, once you have your hookups built, which are discussed on how to make these in the next video, you can go ahead and stack your hat board and your Raspberry Pi just like you normally would, and hook each of these up to their own separate power, and they're good to go. Now, your hat board and your Pi are still communicating. The only thing that's happening here is we are powering them from different power supplies. Two different batteries. And just to show you that this configuration can in fact work given our current chassis, here's one way that you could set up the underside of your chassis. You may need to make some mounts or 3D print them out or whatever you may do. But you can fit two batteries here and your Raspberry Pi and hat board. It's up to you. You can come up with any configuration you want, really, and obviously you're going to need a third wheel to be placed on here, but the two batteries, your hat board, and your Raspberry Pi all hooked up will fit in the underside of your chassis, leaving you the top of the chassis to do essentially whatever you want. But I can't express enough just how important it is to make sure we have good solid connections to our Raspberry Pi and that we're meeting our power requirements the way that's outlined in this video, and we're building our buck converters and our connections the way that it's shown in the next video. If you don't supply a stable current to your Raspberry Pi, it can and will crash. And if you do this over and over and over again, eventually you're going to have to reload the operating system, and you're not going to want to have this happen during the competition. So get this right. The power side of this is of the utmost importance that it's correct, and take your time, do a good job, and let's prevent it from being a problem.